Welcome to this demonstration for testing the strength of the components in this differential. Will the bodies yield under a large load condition? Do we have enough bolts, or should we optimize the design and use fewer? Should we consider changing the size of the bolts? Taking a look at our first plot, we can see there is stress on the middle of the hub. The probe tool will help us to find out if it is going to be a concern. With the stress at 79 megapascals, we know it is not going to be an issue. What about the bolts? Let's begin by taking a look at the axial force that is causing tension or compression on each bolt. The largest amount of tension is 67 newtons. What about shear? The load on the gear is certainly going to impact the possibility of shear on the fasteners. Using these plots, we can check both directions and calculate the total shear for the worst case, which is nearest to the load on the gear. Once again, by using the probe tool, we can check the results anywhere on the model or on any of the 12 bolts. A simple spreadsheet calculation will help us to validate our design for the fasteners. By entering in the axial and shear forces, we can compare it to the allowable values for a specific bolt size and material type. It looks like we will have no problem with this configuration. The factor of safety is well beyond our requirements. Remember, this is a mass-produced assembly. We can save money by reducing the number of fasteners. Let's make the change, and also take a minute to see how this study is set up. First, we will reduce the number of bolts from 12 down to 8. Then the setup for the analysis is simple. We will constrain the center of the hub, which prevents it from moving. Then apply a total force to the teeth on the gear of 5,000 newtons. Next, we have the bolt connectors. There are two options when analyzing designs that have fasteners. First, the 3D models can be left in the study and they will be meshed as solid elements like the hub and the gear. This option involves a lot of work setting up proper contact conditions as well as lengthy solve times. The second option is the use of connectors. They take less time to set up and solve several times faster than solid bodies. As you saw earlier in the video, they also provide results like axial and shear forces on the bolt, and that is exactly what we need to know. Notice the results take into account the material and preload, providing the information we need to make informed design decisions. Now let's generate the mesh and run the solver. Just like the previous design, we will begin with the axial force on the bolts. It looks like the worst case is slightly higher than the 12-bolt design at 73 newtons. Nothing to be concerned with there. How about shear? In direction 1, we have 322 newtons. And in direction 2, we have 1,588 newtons. Now is the moment of truth. Will the 8 bolts be sufficient for this design? The results show the 8-bolt configuration is going to be enough. What about the size? Let's try 6 millimeters. We may even be able to save on size as well with a factor of safety above 5. As you have seen, we are able to run quick what-if scenarios to find the best design possible for the differential, all before a single prototype is built and tested. Autodesk is your trusted solution for testing your designs virtually. It is the future of making things.